Okay, for this video I want to show you how to calculate x and y intercepts in a line, okay? And we're going to use when they're in standard form and when they're in slope-intercept form. Now keep in mind, when you have a line, let's just say we draw a line right here, okay? We have an x-axis and we have a y-axis. So the x and y intercepts are exactly what they sound like. The x-intercept is right here. The x-intercept is where the line crosses the x-axis. And remember that y is equal to 0 at this point. A y-intercept, which we've already talked about when we've talked about slope-intercept form, y-intercept is where the line crosses the y-axis. And remember that x is equal to 0 at this point. Remember that this is exactly what we're talking about when we use that b, when we do y equals mx plus b. So the first thing I'm going to do is take you through a couple of equations that are in standard form, and then I'm going to take you through an equation or two in slope-intercept form to show you how to calculate x and y intercepts. So let's say we have the equation 3x minus 2y is equal to 12. So let's remember that for the x-intercept, you're going to let y equal 0 and then solve for x. So what that means is I have 3x minus 2 and the value for y is 0 equals 12. Now what happens is this just becomes 0. So 3x minus 0 equals 12. So that just goes away. And I get 3x equals 12, and I divide by 3. So x is equal to 4. So the x-intercept of this line is the point 40. Now I want to make sure you understand that it's not 4, it's the point 40. Now for the y-intercept, we are going to let x equal 0 and solve for y. So I'm going to do 3 times x, which is 0, minus 2y is equal to 12. Well, this just becomes 0 minus 2y equals 12. So I get negative 2y equals 12, and I divide by negative 2. So y is equal to negative 6. So that point, remember, is the point 0, negative 6. And that would be the b that we're looking if we were putting it y equals mx plus b. Now, since we've already done this, I want to show you how I would put this into slope-intercept form. Okay? So let's do this. If we had 3x minus 2y equals 12, remember, when we calculated our x and y intercept, our x-intercept was the point 40, and our y-intercept was the point, let's go back, sorry, I gotta look, 0, negative 6. Okay, so let's see if we get the same thing when we put this in slope-intercept form. So remember, we're going to subtract 3x from both sides of our equation. When we're putting it in slope-intercept form, remember we are solving for y. So I subtract 3x and I get negative 2y is equal to negative 3x plus 12, and then I divide by negative 2. So I get y is equal to 3 halves x minus 6. So remember that our m is 3 halves and our b is the 0.0 negative 6, which is coincidentally the exact same thing we got when we did that. Okay, so let's do one more. And remember, these don't always have to turn out pretty. We can have fractions and decimals. The real number system includes a ton of numbers that are not always perfect, right? So let's do our x-intercept first. Let y equal 0. So I have 8x plus 10 times 0 equals negative 10. So I get 8x equals negative 10, and then I divide by 8. So x is equal to negative 5/4. I just reduced that fraction, okay? So my x-intercept is the point negative 5/4, comma, 0. Or that would be negative 1.25, right? Now, to solve for y, when we have a y-intercept, you're going to let x equal 0. So we're going to do 8 times 0 plus 10y equals negative 10. All right? So this means anything times 0 is just 0. So I have 10y equals negative 10. And I divide by 10 on each side. So y is equal to negative 1. So the point we are going to do is that 0, negative 1. And I can try this again by just equals negative 10. I can go ahead and put this in slope-intercept form. Got 10y equals negative 8x minus 10. Divide by 10, and y equals negative 4/5 x minus 1. Notice that these are exactly the same. Okay, so I'm going to show you another example with a line that's in slope-intercept form. Because it's not always going to be easy peasy, right? So let's say I have the equation y equals 1/2 x minus 8. Now, what's nice about this is I already know that my y-intercept is the 0.0 negative 8 because it is in slope-intercept form, right? When y is all by itself, it's in slope-intercept form. So, to solve for the x-intercept, again, I'm going to let y equal 0 and solve for x. It's a little bit more complicated, so I have 0 is equal to 1/2 x minus 8. Now, to isolate x, I'm going to go ahead and add 8 to both sides of the equation, and I get 1/2 x is equal to 8. Now, to get rid of this 1/2, I can divide by 1/2, which means I'm multiplying by the reciprocal, or I can just multiply both sides of the equation by 2, so x is equal to 16. So my x-intercept would be the point 16, comma, 0. So let's try one more so that you guys can be comfortable with this. When I have an equation y is equal to negative 4/3 x plus 2. Once again, we're in slope-intercept form, so our y-intercept is the point 0.02. So to solve for the x-intercept, we're going to let y equal 0 and solve for x. So I plug in 0 for y. That's equal to negative 4/3 x plus 2. I'm going to subtract 2 from each side. Now remember, when I'm trying to solve for something that's being multiplied by a fraction, I'm just going to go ahead and first multiply both sides of the equation by 3. So I get, so I multiply by the denominator, so I get negative 4x is equal to negative 6. All right? Again, these do not need to be pretty, so don't be upset if you get a decimal. So my last step, I'm going to divide by negative 4. Watch your signs. Remember that if you divide a negative by a negative, it is a positive, so x is going to be a positive 3/2, okay, or 1.5. Now, like I said, we're going to normally try to keep things in fraction form. So I know this was a longer video than I had planned, but I wanted to go through enough examples so you guys would feel confident. Please make sure you write all these down.